Oh no, we are YouTubing. All right, ladies and gentlemen, ready? Here we go. Topic is absolute zero. My first question to you is, what do the particles behave like in an object that is hot? Should have tons of people with their hands in the air. Tell me what the particles behave like in an object that is hot. Now, I only got about half of you with your hands in the air, so let me remind you of this. You had hot water, you had cold water, you put food coloring in each one, and then we had this conversation a couple days ago. So let's have the conversation again. How do the particles behave in an object that is hot? Yeah, take it.
The molecules are moving faster.
Molecules are moving very, very quickly. So hot object, okay, it's all moving. Now, what about an object that's cold, like the cold water that you had? Now I should have even more people with their hands in the air because they realize something's going on here. Paul, take it.
They don't move as fast.
They don't move as fast, okay? So they're going, that's awkward. Okay. So yeah, they're moving a little bit more slowly if it's colder. And you saw that when you did the demonstration with the hot and cold water and the food coloring. So now absolute zero becomes an easy but interesting concept. Absolute zero happens at 460 degrees below zero on the Fahrenheit scale. Now, if you're wondering why those other, the C and the K are, actually, do you know why? Do you know what they stand for? Just curious, do you know what they, or what one of them stands for? What? Celsius is the other one, and if you want to know on the Celsius scale about what it is, it's about minus 273. Do you know the K? Just curious, do you know the K?
Kelvin.
It's Kelvin, and it's actually 0 on the Kelvin scale. Now, all of these temperatures are the same thing, just on different scales. And they are the absolute coldest temperature that's achievable by a substance in the universe. Now, I know this sounds weird, but I'm going to pose this question back out to you. Why do you think there is a coldest possible temperature that could be achieved by an object? I'm just going to throw it out there like that and see if I get anybody with their hands in the air. Why is there a minimum temperature that things would have to be able to reach? I got Walters. I got one person thinking they can do it. Two people thinking they can do this. Well, let's do it this way. Let's see if I can pick up some more hands if I do one of these. Hot objects, particles. Cold objects. Absolute zero objects. The coldest possible temperature you could have. What are you thinking, Raleigh?
Is it just when they they're completely stops?
Yes, thank you for dancing like that. They completely stop. Yes, that's exactly it. They completely stop. So the temperature at which atoms stop moving is absolute zero. Now, makes sense. Why can't you get any colder than absolute zero? Why doesn't it just go to minus 461? But Walters is like so down with the absolute zero concept. Why can't you get any colder than that?
Because
Try to go slower than stopped. What? Stop! Okay. Stop more! What? I've already stopped. You can't go any slower than stopped. So this is the absolute coldest temperature. If you could actually get the molecules or particles or atoms or whatever to stop. Now here's the cool part. Scientists can't get there. They can't. They've computed what it should be, and they can't get there. They can get within hundredths of a degree of this temperature, but they can't get to it. They can almost get the particles to stop, but there's always a little bit of motion. And this is a relatively new area of science. And they found something really freaky when you start to chill things this much. You know, you got solids, liquids, and gases. That's something you've probably heard of before. Some of you heard about gas a little bit earlier over in this area. I heard it too. But when things are warm, they're gas, like steam. That's hot, right? And you can condense that, cool it down into a liquid at, let's say, room temperature. And then you can cool it down even more into like a solid, which would be like ice. Scientists are finding that when you approach absolute zero, there appears to be another state of matter that scientists are having a hard time describing. Now, I would love to get in and teach all this kind of stuff. However, it doesn't really fall into our curriculum. So what I'm going to do is on my webpage, I'm just going to point something out to you that you may want to see. On my webpage, which I'll pull up for you here, there's a link that says Absolute Zero, Journal Absolute Zero. This is going to bring you to a YouTube video that shows you what scientists are doing right now to try to basically have the quest for the coldest thing. And it's really difficult to understand, but it's cool. It's a Nova special from PBS, which kids very often really like. So if you're super bored, got nothing to do, check out that link. I think you'll find it somewhat interesting. Cool. That rounds out our journal.